Okay, so today what we're going to do is we're going to use quadratics and we're going to change from the standard form of a quadratic into the vertex form of a quadratic. Why might we do this? Well, different forms of quadratics give us different advantages. The standard form allows us to know what the values of A, B, and C are in a typical equation. It also lets us know what C is, which happens to be the y-intercept in a standard form. The vertex form, just like the name says, lets us know what the vertex is. In this case, it's H and K. It also allows us to graph it much easier and do transitions much easier. So we're going to start off with this very first quadratic equation, x squared plus 4x plus 7. All right, the very first thing we want to worry about is we want to make sure our A value is a 1. And we have that with this equation. The A value in front of the x squared is a 1, so that's the good thing. We don't need to do any kind of factoring yet. The next step, we are going to try to take this and turn it into a perfect square trinomial using a process called completing the square. So, obviously this is not a perfect square trinomial, because if I was to take half of 4 and square it, I would get 4, not 7. So, we're just going to use the first two terms. I'm going to put parentheses around them. Now I have two parts. I'm going to turn this into a perfect square trinomial. I need to find a brand new C value. So to find C, we're going to use B, the value for B. We're going to cut it in half, and then we're going to square it. All right, so in this case, my B value is 4. I take half of 4 and square that. Half of 4 is 2. 2 squared is 4. I have my brand new C. I'm going to add C on the inside of the parentheses. So now I'm going to rewrite it. It's going to be y equals x squared plus 4x plus 4. Close parentheses. But make sure you include the plus 7 on the outside. Remember, that's still part of the equation. So now inside my parentheses, I have my perfect square trinomial. I can work with that. Now, only one problem here. You can't just go and keep adding things into an equation. You got to keep your equation balanced. So here I've added 4. Normally, whatever I do to one side of the equation, I'll do to the other. But I'm still trying to solve for y, so I don't want to add 4 to that side. So what I'm going to do is if I added 4 on the inside, I'm going to subtract that same amount from the outside. So I'm really not adding anything extra. Because whatever I add here, I take away here. All right, now we're one step away from actually writing the vertex form. It's going to be y equals. Now I'm going to take my perfect square trinomial, and I'm going to turn that into a binomial squared. So if I have x squared here, we'll have an x in the very front. That's why we needed to have x squared, and we needed to have a equal 1 initially. The next number that goes here is just going to be half of b. So in this case, it's going to be a plus 2, and then I'm going to square that. Because if I was to go through and FOIL this, I could turn this directly into that perfect square trinomial. And the only thing that's left is just clearing up what's on the outside. 7 minus 4 is 3. So I have converted from a standard form of a quadratic into the vertex form. All right. Now, what happens if we have a number out in front of the x squared? There's an additional step for that. So let's do one of those problems. Let me just check my lighting real quick. There we go. And the next problem is going to be y equals 3x squared plus, we'll do minus 6x. We'll go with plus 8. There we go. All right. So now we don't have an x squared. Remember, initially we want to get to a point where a equals 1. It doesn't. It equals 3 right here. So what we're going to do is we're going to put a parentheses around. We're only going to work with the first two terms. And that's what we're going to turn into our perfect square trinomial. Now, what we have to do here is we're going to factor out the 3. We're going to pull a 3 out of the first term and pull a 3 out of the second term. So if I factor that out, It's going to be y equals, I'm going to put a 3 on the outside. I factor 3 out, I'm just left with x squared, which is what I'm looking for. But I also have to take a 3 out of the negative 6. So two numbers that multiply together give you negative 6. Well, 3 times 2 is 6. So this would be 3 times a negative 2. We'll put an x in there. All right, would be 6 and plus 8. We don't factor anything out of the one that's outside the parentheses. So yeah, these are two factors because 3 times negative 2 will give me a negative 6. So we're all set. We have our x squared. Now we're back on track. The next thing we need to do is find a brand new c. Remember, that's where we take half of b and then we square it. So half of b would be negative 2 divided by 2 squared. Negative 2 divided by 2 gives me a negative 1. Negative 1 squared is just a 1. Then once again, we're going to add that to the inside of the parentheses. And that's right, we're going to subtract it from the outside of the parentheses. That way we're not adding anything extra to the equation. So now it's going to be y equals 3x squared minus 2x plus 1 on the inside. We still have the plus 8 on the outside. And now we're going to subtract 1 from the outside. All right, so far so good. Now, one thing we have to add to this. Technically, this 1, I would eventually multiply by the 3. Because this is like, it's the distributive property. I mean, actually, I would need to, if I want to incorporate the 3 back into the trinomial, I got to multiply everything by 3. So in other words, if I have to multiply this 1 by 3, I have to do the same thing for the negative 1. So out here, whatever you factor out, you're going to multiply what you're subtracting by that same number. All right, so we're going to multiply this negative 1 by 3. Now we're ready to get to the vertex form. So y equals 3. Now we're putting in our parentheses. We're doing the x minus h part. Here's the x. The x goes in here. The squared, or the exponent of 2, goes outside. And remember, you take half of your b. So negative 2 divided by 2 will be a negative 1. There's my binomial squared, which I could use to get my perfect square trinomial. Now I have to go here. Now you remember, you have to use the order of operations. You can't just go left to right all the time. All right, so negative 1 times 3 gives you a negative 3. So really out here, it's like saying 8 minus 3. And then 8 minus 3 is 5. So this would become plus 5 on the outside. And now, once again, I have my vertex form. Now, remember, I can tell by this, I can tell what the vertex is. My vertex would be 1, 5. I can tell by the A that it's going to be a rather narrow and very steep parabola. So there's a lot I can tell from this. So hope this helped you out today. If you have any questions and you're in my class, please ask me in class. If not, give me a little like down below and maybe leave a comment. If there's something you want me to go over and help you out in your class, be sure to ask. Take care.